Welcome to Maths for You YouTube channel. A past question on mechanics. A particle P of mass m and a particle Q of mass lambda m are attached to the two ends of a light inextensible string which passes over a smooth fixed pulley. There are words meaningful. The light inextensible string, so there's no weight, no elasticity, and again it's a smooth pulley. There's no friction involved. The system released from the rest with a string taut, so as tension, as shown in the figure. The particle P moves downwards with an acceleration of g over 2. Show that lambda equal 1/3. Let's start with the first part. So it's a diagram given. I've just redrawn the diagram with the forces. Right, the m is mg, of course, in Newton, and the tension T upwards, and then tension T is same all along the string because of it's smooth pulley. And again, as the m is traveling downwards with an acceleration of I put a here, a equal g over 2. And then of course this will go upwards with the same acceleration, right? Okay, let's so the forces on m, let's look at the forces on m downwards. M is the forces on m is the weight is mg, m times g, minus t upwards, the tension, that's the force. Forces on lambda m, that O is P, Q. So that's forces on m is P, and force on lambda m Q. Forces on Q is upwards, T is great, of course, T minus lambda mg. So now we need to apply Newton's second law equation, the F equal ma. F equal ma equation. F is the force, m is the mass, a is the acceleration. Change of velocity, rate of change of velocity, of course. Right, F, I'm choosing it for P, F equal ma, the forces acting on downwards is mg minus t, equal m is the mass and a is the acceleration. And for Q, that's for Q, T upwards, T minus lambda mg equal lambda ma. This equation 2. Right, with this two equation, we can add one another. So 1 plus 2, the t cancelled out, minus t and plus t cancelled out. All we have, mg minus lambda mg equal the right hand side, ma plus lambda ma. And we can cancel out simply all the m's gone. What we have, g lambda g equal g over 2 m and lambda a. This a and lambda a. But we know left hand side g minus lambda g, the right hand side you just substitute a for g over 2. So g over 2 plus lambda times g over 2, again g, all g cancel out. What we have on the left hand side is 1 minus lambda, the right hand side is half plus lambda over 2. Bit of simplification, lambda plus lambda over 2 equal 1 minus half, that is 3 over 2 lambda equal half is lambda equal 1/3. That is exactly what we have been asked to prove or show. That's done. Second part, if the particle P strikes a horizontal inelastic floor Well, just there's no forces, losing forces and all other things. So just ignore that wording. We don't need to worry about that wording. With a speed v, that's important, v, and the particle q never reaches the pulley, find the time taken by the particle q to reach the maximum height from the instant when the particle p struck the floor. Right. When this traveling with the tension, string and tension is traveling, as soon as that the particle p hit the ground, then the tension may no longer, or the string may no longer in action. So the no T. So Q, soon as that P hit the floor, then of course the P coming down and Q going up. And when the P hit the floor with the speed of V, at that time Q has the same speed as well, because of it's the string attached to both weights. As soon as that P hit the ground, then as I said, the string no longer active, but the Q, even though has the velocity v, but from then on, the Q will be under gravity. So it will actually go with the velocity there, it will go up until it's reached its velocity 0. So its gravity will bring the speed to 0. So that we can use that SWAT equation for Q, of course. V equal U plus AT. V, because of U, will reach the velocity to stop. So it just will go to stop. That V equal, the final velocity is 0. And the initial velocity, and when the P hit the ground, initial velocity of Q is V. So V, then again gravity upwards. So we are using upwards, the gravity is minus G, and T. T is the time taken. So from the moment P hit the ground, the Q has the velocity of V. From then on, the Q will coming under the gravity. Therefore, it will actually reduce the speed until its speed reach 0. So that is exactly what they're asking us, from V to 0. So 0 the final velocity, U is the V is the initial velocity minus GT. From that, T equal V over G. So the time taken to reach the 0 velocity, or the highest height of Q, is V over G. From the time P strikes, I just put a little wording, from the time P strikes the floor, Q will be under gravity. You have to write this sentence or in the something to explain how we reach to use this equation and find T. That is very important. Yeah, just write it down, just how it happens. So the P hit the ground and Q has the same velocity, and after that the Q coming under gravity, and all that information should be important for the examiner to check. Thank you. Please subscribe the channel and share the contents with other students and friends. Thank you.